This video focuses on Visual Sim Architect support for polymorphic interfaces. Now, one of the issues that we've become aware of within our customer base is the desire for flexible modeling. And one of the things we found with other programming languages that are strongly typed is that you have to know the type of interface and structures going into the interface in order for those languages to work. But that makes it extremely problematic in system level design because the models in system level design evolve, they change, and one of the changes that are made is that the transactions change and the ideas of what you want to communicate change. And so we wanted to have the ability to support such flexibility and also evolution of system level designs. Now, when we talk about transactions, transactions are instances of a data structure. So you'll have a data structure defined at the very beginning, and the transactions are simulation time instances of those data structures which are used to communicate information from one block to the other. Visual Sim Architect supports polymorphic types by the following. The first is that the port types are often specified as type general, which can allow any transaction to come in. And in addition to this, we have the ability within Visual Sim Architect to actually change transactions, not only by changing the values within existing fields, but also by allowing the ability to add and delete fields to and from the transaction. And the advantages of being able to do so is that it increases model flexibility, it decreases model complexity because you don't have to worry about data types. The block ports don't require specific data types like strongly typed languages do. And therefore in your model most of the ports are going to be of type general. And finally, the blocks that either the engineer creates or the ones that are contained in Visual Sim Architect typically use this ability to add in fields to a data structure by adding either functional information such as the fields needed for downstream blocks that are required by the rest of the design, or you can add non-functional information such as block statistics. And these statistics are not used by any of the other blocks but are very good ways of monitoring within any part of the design what the design is doing and how the different pieces of the design are working. So consider the following design in Visual Sim Architect. Here we have a transaction source that is outputting transactions to a processing block which transforms the transaction, and in our case, as you'll see in a second, we're adding a couple of fields to the incoming transaction and outputting that transaction to the rest of the system, in this case a text display which will allow us to view that transaction. And one of the things I'm going to be showing is a comparison between the transaction that is input to the processing block and the transaction transformed to the output text display. Now, the transaction source has defined or declared in it the transaction type called header. This is the transaction that's going to be output. Now, the header data structure is a data structure that either the user might have created or that we have predefined within Visual Sim Architect. And it is a declaration of the data type that the header represents. It contains several fields: block, DS name, delta, time, index, and ID. And this is the starting data structure for the transaction. Now, when the header transaction comes into the processing block, what we're doing there is we are adding 2 additional fields to the transaction, thereby supporting this whole idea of polymorphic interfaces. It is adding a field that didn't exist before called time created, and it is adding a field also that didn't exist before called service time. Now when we run the simulation, on the left-hand side, this is the input transaction. And this input transaction has those 6 fields of the original header data structure. On the right-hand side, we have the transformed data structure as a result of the processing block executing the sequentially the assignment statements. And we see that the 2 additional fields, service time and time created, are added to the transaction, thereby changing the transaction with those modifications. And the port types of the processing block are of type general, which allow any transaction to come into that port of the input port and any transaction to go out of that output port. And this is the way that we support polymorphic interfaces. This ends the video on polymorphic interfaces.